Welcome, my friends. In this video, we will continue practicing with the unit circle. Let's look at a problem. Suppose that theta is an angle in standard position whose terminal side intersects the unit circle at the point -8/17, 15/17. We are asked to find the exact value of all 6 trig functions. Recall that the x-coordinate of the unit circle is equal to cosine of theta, and the y-coordinate is equal to sine theta. That means we get 2 out of the 6 trig functions for free. Cosine of theta is equal to -8/17, and sine of theta is equal to 15/17. Recall that secant of theta is just the reciprocal of cosine of theta. So that means that secant of theta is -17/8. Cosecant of theta is the reciprocal of sine of theta, which means that cosecant of theta will be 17/15. Tangent of theta is just sine over cosine. So we can take our value for sine, which is 15/17, and divide by our value for cosine, which is -8/17. If we reciprocate the denominator and multiply, we will have 15/17 multiplied by -17/8. These 17s will cancel, and we will be left with -15/8. Tangent of theta is equal to -15/8. Cotangent of theta is the reciprocal of tangent, which means that cotangent of theta will be -8/15. Let's look at another problem. Suppose that theta is an angle in standard position whose terminal side intersects the unit circle at the point 3/4, -7/4. We are asked to find the exact values of all 6 trig functions. Just like last time, we get cosine and sine for free. Cosine is the x-coordinate, which is 3/4. Sine is the y-coordinate, which is -7/4. Secant is the reciprocal of cosine, which is 4/3. Cosecant is the reciprocal of sine, which is -4/7. This is considered to be in an improper form. We don't like to leave a square root in the denominator. We can rationalize the denominator by multiplying by the square root of 7 divided by itself. This is allowed because we are just multiplying by a unique form of 1. The square root of 7 over itself is just 1 and won't change the problem. If we simplify this, we will get -4 times the square root of 7 divided by 7. Since the square root of 7 times itself is just equal to 7. Tangent is sine over cosine. So we have -7/4 divided by 3/4. Just like last time, we can reciprocate and multiply by the denominator, so that we have -7/4 times 4/3. The 4's will cancel, and we will be left with -7/3. Cotangent is the reciprocal of tangent. So we have -3 over the square root of 7. Again, we will have to rationalize the denominator, so we will multiply by the square root of 7 over itself. Simplifying, we will have -3 square root 7 divided by 7. Let's take a look at a different type of problem. Let's say that we are asked to evaluate cosecant of 30 degrees. Recall that cosecant is just the reciprocal of sine. Hopefully you know that sine of 30 degrees is 1/2. That's one of the commonly known angles on the unit circle. That means that cosecant must be the reciprocal, so cosecant of 30 degrees is going to be 2/1, which is just 2. How about tangent of pi/3? Now, in my previous video, I showed you the common angles for tangent on the unit circle, but if you forgot or have not memorized those quite yet, here is what that looks like. So the way I remember tangent is that it increases as you go up the circle, kind of like sine. So at pi/6, we have square root 3/3, at pi/4, we have 1, and at pi/3, which is the angle we have square root of 3. Alternatively, if you're not sure or you don't remember that tangent of pi/3 is the square root of 3, you can just take sine over cosine. Sine of pi/3 is square root 3/2, and cosine of pi/3 is 1/2. You can reciprocate and multiply so that we have square root 3/2 times 2/1. The 2's will cancel, and you will get the square root of 3. Let's try to find secant of 210 degrees. Recall that secant is just the reciprocal of cosine. That means if we can find cosine of 210 degrees, we can find secant of 210 degrees by taking the reciprocal. Let's locate 210 degrees on the unit circle. 210 degrees is somewhere between 180 and 270 degrees. More specifically, 210 degrees is 30 degrees below the negative x-axis, which means that our reference angle will be 30 degrees. we already know that cosine of 30 degrees is square root 3 over 2. That is one of our commonly known angles that you should have memorized. Cosine of 210 degrees is going to be negative square root 3 over 2, because 210 degrees is in quadrant 3, where x is negative. That means secant of 210 degrees will be the reciprocal, negative 2 over the square root of 3. But of course, we don't like to keep a square root in the denominator, so we can multiply by the square root of 3 over itself. This will give us negative 2 square root 3 in the numerator and just 3 in the denominator. Secant of 210 degrees is negative 2 square root 3 over 3. Let's try to find cotangent of 11 pi over 2. 11 pi over 2 is not found on one rotation of the circle, but we know that if we subtract multiples of 2 pi, we can eventually find a coterminal angle with 11 pi over 2 that is in one rotation of the unit circle, which might be a little bit easier to think about. Instead of subtracting 2 pi, I can subtract 4 pi over 2, which is just a fancy form of 2 pi that has the same denominator that we have in our fraction. We will get 7 pi over 2, which, of course, is still not within one rotation of the circle. Let's subtract 4 pi over 2 one more time. We will get 3 pi over 2, which indeed is in one rotation of the circle. 3 pi over 2 and 11 pi over 2 are coterminal, meaning that cotangent of 11 pi over 2 will be equal to cotangent of 3 pi over 2. At this stage, hopefully you can envision where 3 pi over 2 is on the unit circle. 3 pi over 2 is along the negative y-axis at the point 0, negative 1 on the unit circle. We know that tangent is y over x, and cotangent is the reciprocal of tangent, meaning that cotangent is x over y. If x is 0 and y is negative 1, then cotangent will be 0 over negative 1, or just 0. Cotangent of 11 pi over 2 is just equal to 0. Let's try to find cosecant of negative 495 degrees. Now again, negative 495 degrees is not on one rotation of the unit circle, so you might want to add 360 degrees a few times to find a coterminal angle that's a little bit easier to think about. If we add 360 degrees once, we will get negative 135. If we add 360 again, we will get 225. Negative 495 degrees and 225 degrees are coterminal, which means that cosecant of negative 495 degrees will be the same thing as cosecant of 225 degrees. Cosecant is the reciprocal of sine, so if we can find sine of 225 degrees, we can reciprocate to find cosecant of 225 degrees. Let's take a look at the unit circle. 225 degrees is somewhere between 180 and 270 degrees. More specifically, 225 degrees is 45 degrees below 180 degrees. Therefore, our reference angle is going to be 45 degrees. Sine of 45 degrees is one of the commonly known angles. It's the square root of 2 over 2. Since 225 degrees is in quadrant 3, which is below the x-axis, sine of 225 degrees will be negative square root 2 over 2. Cosecant of negative 495 degrees or 225 degrees, doesn't really matter since they are coterminal, will be the reciprocal of negative square root 2 over 2, which is negative 2 over the square root of 2. If we rationalize the denominator by multiplying by the square root of 2 over itself, we will get negative 2 square root 2 over 2. The 2's cancel, and we just have negative square root 2. Cosecant of negative 495 degrees is just negative square root 2. Let's try a few more problems. If theta is equal to 4 pi over 3, we want to find the exact value of the following three expressions. First, we have cosine of theta over 2. If we want theta over 2, then we can simply multiply theta by 1/2. 4 pi over 3 multiplied by 1/2 would just be 4 pi over 6. So cosine of theta over 2 is the same thing as cosine of 4 pi over 6. This can be reduced to cosine of 2 pi over 3. Now, I'm not going to pull out the unit circle here, but maybe you can envision it in your head. The reference angle for 2 pi over 3 would be just pi over 3. Cosine of pi over 3 is 1/2, but 2 pi over 3 is in quadrant 2, where cosine would be negative. So cosine of 2 pi over 3 is negative 1/2. Next, we have 2 times the cosine of theta. That'll just be 2 times cosine of 4 pi over 3. So all we have to do is figure out what cosine of 4 pi over 3 is and multiply it by 2. 4 pi over 3 is somewhere in quadrant 3. 3 pi over 3 would be the negative x-axis, so we are 1 pi over 3 below that. The reference angle will be pi over 3, and again, cosine of pi over 3 is 1/2. We are going to be in the third quadrant where cosine is negative, so cosine of 4 pi over 3 will also be negative 1/2, but we need to multiply that by 2. 2 times negative 1/2 will just be negative 1. In the last problem, we are asked what cosine squared of theta is. For trigonometric functions, we typically write the square or exponent in the middle. If we wrote the exponent on the edge, it would kind of look like it is on the argument of the function, so typically you will see the exponent written in the middle. So this is really the same thing as saying take cosine of 4 pi over 3, what theta is, and then square it. So we will do this in order from the inside out. First find cosine of 4 pi over 3, and then square your answer. Well, we already know from the previous problem that cosine of 4 pi over 3 is negative 1/2, so all we have to do is take negative 1/2 squared. Squaring both the numerator and denominator, we will get 1/4. Cosine squared of theta is just equal to 1 over 4. Let's try one last set of problems. If theta is equal to 225 degrees, let's find the exact value of the following three expressions. First, we are asked for sine squared of theta. Again, this just means find sine of theta and then square your answer. So this is the same thing as sine squared of 225 degrees. Now hopefully you can envision where 225 degrees is on the unit circle. This is 45 degrees below the negative x-axis, so our reference angle will be 45 degrees. Sine of 45 degrees is the square root of 2 over 2, but since we would be in quadrant 3 where y is negative, this will be equal to negative square root 2 over 2. The negative ends up not really mattering too much because we're going to square our result, which will cancel the negative. If we take negative square root 2 squared, we will get 2, and 2 squared is just equal to 4. Reducing, we get 1/2. Sine squared of theta is equal to 1/2. Next, we have sine of 2 theta. That's the same thing as sine of 2 times 225 degrees. 2 times 225 is 450, so this is the same thing as sine of 450 degrees. 450 degrees is not on one rotation of the circle, so we can subtract 360 to find an angle that is on one rotation of the circle. That might be a little bit easier to think about. 450 minus 360 is equal to 90, so this simplifies to sine of 90 degrees. At 90 degrees, we will be straight up the y-axis, and the point in the unit circle would be 0, 1. Since sine is the y-coordinate on the unit circle, sine of 90 degrees is just equal to 1. Okay, one last problem. We have sine of negative theta. That's the same thing as sine of negative 225 degrees. If we'd like to think of a coterminal angle that is on one rotation of the unit circle, we can add 360 degrees to our argument. We get sine of 135 degrees. 135 degrees is 45 degrees above the negative x-axis in quadrant 2. Sine is positive in quadrant 2, so this is going to be equal to the square root of 2 over 2. Alright my friends, that finishes this video with more practice using the unit circle.